Hello, everyone. Before we left for break, I had mentioned that we have a test on Monday when we return due to the snow day. And I was going to make available an extended review and make a YouTube video with the solutions. So this is that video. This extended review guide will help you study for the test that's on Monday. So let's get started. On number one, we're given a triangle, and we need to find the third angle when given two other angles. Well, what we can do here is we can use the triangle sum theorem, which means we start at 180 degrees, and we subtract the remaining angles. In this case, it's 68 and 45. 68 and 45 is going to be 113. 180 minus 113 will be 67 degrees, and that is the angle X. Question number two. Here we're given a triangle with one exterior angle and two interior angles. The exterior angle theorem states that the two opposite interior angles add up to the exterior angle. So let's set up an algebra equation to model that. We have 5x plus 90 equals 20x minus 15. Here I'm going to add 15 to 90 and I get 105. I'm going to take 20x and I'm going to subtract 5x and I get 15x. I'm going to subtract 15 on both sides and x is equal to 7. And they want us to solve for x, so that is the answer. Question number three. Here we're given an isosceles triangle in which we are given the base angles of the isosceles triangle. These are the angles opposite the two congruent sides. And the isosceles angle theorem states that the base angles of an isosceles triangle are indeed equal. So we can set these two expressions equal to one another. So on one side, we get 2x plus 42. On the other side, we get 4x plus 28. All right. On one side, I'm going to take 4x and I'm going to subtract 2x and I'm going to get 2x. On the other side, I'm going to take 42 and I'm going to subtract 28 and I'm going to get 14. Dividing both sides by 2, I get x equal to 7. Here, they want us to find the measure of each angle. So we know that angle J and angle H are equal, so let's evaluate that. So if we put 7 into 2x plus 42, so this is going to be 2 times 7 plus 42. 2 times 7 is 14. 14 plus 42 is going to be 56 degrees. So we know that angle J, let's put it up here, I guess. Angle J is going to be 56 degrees. Angle H is going to be 56 degrees. And then finally, we just have to use the triangle sum theorem to evaluate angle I. So we're going to start with 180. And I'm going to subtract the angles given, 56 and 56. 50 and 50 is 100, 6 and 6 is 12. 180 minus 112 is 68. And that's going to be our third angle here. So we get 68, 56, and 56 as the solutions. Question number 4. If the triangle is equilateral, find the value of x, y, and z. So a couple of things about an equilateral triangle. In an equilateral triangle, we know that the three sides of a triangle are congruent and that each angle is equal to 60 degrees. So given this fact, we can solve for z right away. So z plus 5 is 60. And then I subtract 5, and z is equal to 55. So we found one of our variables to be 55. Now I have three sides. Two of them have an x, and one of them has a y. So let's evaluate x next. So in this case, it's going to be 3x minus 2 equal to 2x plus 5. We have 3x minus 2x is going to be 1x, and 5 plus 2 is 7. So we now evaluated x. And then finally, now I know that x is 7. I can plug x into one of the sides. I'm going to pick 2x plus 5 and evaluate what the side measure is, and then I can set it equal to y plus 3. So up here we'll do 2 times 7 plus 5. So 14 plus 5. We get 19 for one of the side measures. And now that we know what the side measure is equal, we know that y minus 3 is equal to 19. We add 3 to both sides, and we get y equal 22. So we have now evaluated all three variables. Question number 5. Can these lengths create a triangle? So when dealing with is it a triangle or it is not a triangle, you take the two smallest sides and you add them up, and they need to be greater than the third side. This is called the triangle inequality theorem. So in our first example here, 3 and 8 are the two smallest sides. 8 plus 3 is 11, and 11 is indeed greater than 9. So that's a yes. So that is a triangle. And then in example B here, we have 11 and 20 are the smallest sides here. So we do 20 plus 11 is 31, which is less than 32. Also equal. If the third side is equal, you do not get a triangle either. So because the added sides are not greater, we would say the answer is no. Question number 6. All right, in questions number 6, we want to list the angles from least to greatest. So this is the angle side relationship theorem, where the largest side is opposite the largest angle, and the smallest side is opposite the smallest angle. So let's start with the least. So we know 5 inches is the least here. We're going to work ourselves backwards, and we know that angle G is the smallest. Then we're going to look at the medium, 6, working backwards to angle H. And lastly, 11 is the largest side. Working backwards, we can see that angle J is the largest side. So GHJ. Number 7. All right, to number 7, write the possible values of x in an inequality. So specifically, when given two sides of a triangle and you need to identify the window of sides that create a triangle, we need to use the triangle inequality, compound inequality. So in this case, we're going to have a low end, and we're going to have a high end, right? To establish the low end, we take the two remaining sides and we subtract them. So big minus little, so 14 minus 13. And in order to get the high end, we are going to do 14 plus 13. Okay. So on the low end, we get 1. And on the high end, we're going to get 27. And that's all they want. They just want the inequality. So that is the final answer. Question number 8. All right, so we have given a bunch of angles here, and we need to find the question mark right here. So in order to do that, we should probably work our way left to right. So right here, this 45 degree is a vertical angle. So we know that this is indeed 45 degrees here. We can find the third angle by doing 180 minus 60 plus 45. And that is equal to 75. Okay, so we know that this right here is 75 degrees. And now here we can see that these three angles form a line, right? So again, they're linear angles, so they also add to 180 degrees. So again, we can take 180 and we can subtract 75 plus 68. And this time we get 7 and 6, 130. So we get 37 degrees. So we know that this angle right here is 37 degrees. And now, based on this, we now can use the exterior angle theorem. So 137 are opposite interior angles to the exterior angle. So if we just simply do 100 plus 37, we get 137 degrees, which is also the exterior angle of that triangle. Question number 8. All right. So, question number 9. So, on question number 9 here, we are given some angles and we have to find x. So, again, we're going to work left to right. So here we have a set of vertical angles here, making this a right angle. We can use triangle sum theorem once again, 180 minus 40 plus 90. And this is going to be 90 minus 40 is 50 degrees. So we know that this is a 50 degree angle. These form a line. So again, we have linear angles, so we can take 180 and subtract 60 plus 50. And in this case, we're going to get 70. 110. So this is 70 degrees right here. And then there's a variety of things that you can do here. But again, I'm seeing the exterior angle theorem here. So if I take the exterior this time and work backwards to the opposite interior, I can just subtract 130 minus 70 and find my angle x. So 130 minus 70 is 60. So I know that x is 60 degrees. Question number 10, halfway there. So in question number 10, they have two triangles here, and they give us a bunch of information about the left triangle. And all they tell us about the right triangle is that it's isosceles. But the interesting thing about this problem is the isosceles triangle really doesn't play a role in the solution at all. So I'm looking at the left triangle only, and it looks like each of the angles is defined by an expression. I can use the triangle sum theorem to figure out what x is. The triangle sum theorem states that all angles of a triangle add up to 180 degrees. So we're going to take each of these expressions. We have 2x minus 10. We have 6x. And we have x plus 10. And I'm going to set those equal to 180 degrees. So now, combining like terms, 2x and 6x is 8x. 8x plus 1x is 9x. And then we have negative 10 and positive 10 cancel each other out. And this is just going to be equal to 180. Divide both sides by 9, and I get x equal to 20. All right, question number 11. Question number 11 is a very simple triangle sum theorem once again. We're going to start with 180 degrees, and we're going to subtract the two remaining angles, 78 and 72. 7 and 7 is 140, 8 and 2 is 150, and we are left with 30 degrees at the end of the day. So this angle S is 30 degrees. Question number 12. Okay, in question number 12, we first have three questions to answer. What kind of triangle is this? How do you know? And find the value of X and Y. So this is the dead giveaway right here. Yes, there's two tick marks indicating an isosceles triangle, but they tell us that one of the angles is 60 degrees. And when that happens inside a triangle, we know that it has to be an equilateral triangle. Okay? How do we know? The 60-degree angle. And then let's find X and Y. So first, I think it might be best to solve for Y first, because we would simply have 6Y equal to 60. Divide both sides by 6, and we get Y equals 10. And then lastly, we know that all the sides are equal, including this third side, doesn't matter. But 3x plus 8 is equal to 23. Okay, we're going to subtract 8 from both sides. We get 3x is equal to 15. And then divide both sides by 3, and we get x equal to 5. And so now we've solved for x, solved for y. It's equilateral because it's 60 degrees. And those are all of the answers to this problem. Question number 13. All right, so they tell us in question number 13 that a triangle ABC is an isosceles triangle. AB is equal to BC. So if it helps, sometimes you might want to draw a picture here. So we have AB is equal to BC. So there's our isosceles triangle. AB is 4x plus 10. And BC is 2x plus 28. And sometimes when you draw it out, it becomes very straightforward. So as we draw this out, we can see, 4x plus 10 is equal to 2x plus 28. All right. So once again, 4x minus 2x is 2x. 28 minus 10 is 18. And then x is equal to 9. And they want us to find the length of AB. AB is 4x plus 10, so 4 times 9 plus 10. 36 plus 10 is 46. And that's going to be the length of AB. Question number 14. All right, so in question number 14, it looks like we are given the exterior angle and the opposite interior angles of a triangle in an algebra expression form. All we have to do is find x and then find angle SRP. So the exterior angle theorem states that the two opposite interior angles add up to the exterior angle. So we know that 5x minus 1 plus 23 is equal to 9x plus 2. All right, and then we'll solve here. Looks like we have 23 minus 1 is 22. 22 minus 2 is going to be 20. 9x minus 5x is 4x. And then we divide both sides by 4, and we get x is equal to 5. So we've solved for x here. And now we have to find angle SRP. So SRP right here. And we just plug x into 9x plus 2. So 9 times 5 plus 2. So 9 times 5 is 45. 45 plus 2 is 47. And we can just pop that there. And we have our two answers. Question number 15. So in question number 15, we have find the values of x, and then we have to find two of the angles here. So I see a couple of isosceles triangles, and the isosceles triangle theorem states that base angles of an isosceles triangle are equal. In other words, the sides opposite the congruent sides are also congruent. So we know we have 64 degrees here, and we know we have x degrees here. Okay, and well, let's start with x, I guess. So this angle and this angle form a linear pair. So if I take 180 and I subtract 64, we'll get 116, which will give me the measure of this angle right here. So this is 116. Now I can use the triangle sum theorem to solve for x. So okay, angle. So let's do that. We have x plus 116 is equal to 180. 2x equals 180 minus 180, 70, 54. Divide both sides by 2, and 64, sorry. 60. Because 180 minus 100 is 80, 70, 64. Divide by 2, we get x is equal to 32 degrees. So there is angle to, the measure of angle x is 32 degrees. Now let's find the measure of EGF. So EGF, we already did that, 116. A little off there, but that's the answer there. And DGE is just the linear pair of 116 or 64 degrees. So we have the answer to, and 32 is x. All right, question number 16. All right, question number 16. We have in triangle WIN, they give us the three angles. Angle W is 2y plus 7, angle I is 6y, and angle N is 8y plus 13. Find y. So a classic example of the triangle sum theorem. So in other words, we'll take our angles here. 2y plus 7 plus 6y plus 8y plus 13 is 180 degrees. 2, 6, 8, 8 and 8 is 16y. 7 and 13 is 20. Subtract 20 from both sides, we get 16y equal to 160. Divide both sides by 16, and you get y equal to 10. And that's all they want, just y. So question number 17. All right. The side lengths of a triangle are 12 and 20. Write a compound inequality. Write an inequality to demonstrate the side lengths of the third side. So this is like one we did before. We have a low end and a high end. To get the low end, we subtract 20 minus 12. And on the high end, we add them, 20 plus 12. So on the low end, we get 8. And the high end, we get 32. And that is all they wanted. Yep. Question number 18. All right, order the sides and angles from least to greatest. So in order to find the missing side, the missing angle, we just need to use the triangle sum theorem. So we take 180 and we subtract 78 plus 48. 70 plus 4 is 110. 110 plus 16 minus 180 is 54 degrees. So this is 54 degrees. Okay. And then from here, the sides and angles are the angle side relationship theorem. So least to greatest, let's start with 48. 48 is angle N. And angle N is opposite ML. All right, let's go to the medium. The medium is 54 degrees, so that's angle L. And opposite that is MN. Just think, if angle L is the one you're looking at, right, what are the two letters that aren't associated with angle L? So MN. And then finally, what is the largest angle? 78. So that is going to be angle M. What are the two letters not associated with angle M? L and N. And that's it. Number 19, two left. All right, same deal as the last problem here. It looks like what are the sides and angles from least to greatest? So in order to find that third side, we have to use the triangle sum theorem. We start with 180 and we subtract 92 plus 51. 143. So with this we get 37. And now same drill as before. We're going to start least to greatest. So we're going to start with 37 degrees, which is angle C. And then what are the two letters not associated with angle C? A, B. All right. And then we're going to go with the medium. That's 51. That's angle B. And AC. All right, and lastly, angle A, the obtuse angle. We discussed that in class, how the obtuse angle always has to be the largest angle. That's angle A, and BC is associated with that. All right, so down to our last question here on the review. Number 20. So it looks here, what are the sides and angles, once again, from least to greatest? Same drill as the last two questions, only this time we're given the sides, but it works exactly the same. So let's start with the least. At 17, working backwards, we know it's going to be angle N. What are the two letters not associated with letter N? That's going to be Q and R. Next is going to be 21. That's angle R. And then angle R is going to be N and Q. And then lastly, the largest side is NR. And we look here, and angle Q is opposite angle R. So we have three sides, three angles, least to greatest. So that's going to do it for the extended review. Of course, as you're studying for the test on Monday, if you have any questions, send me an email. I'll reply back with some solutions. Have a good break.